Yes. Hi everyone. I am SS Kiran. I am dealing course is electromagnetic waves and the transmission lines. Okay. Last video I have discussed about Poisson's and Laplace equations. Okay. In this video I would like to discuss about capacitances. Okay. Capacitances are parallel plate capacitor and coaxial capacitor and spherical capacitor. Now in this class I would like to discuss about capacitances. Okay. Now today's topic is capacitances or capacitance. Okay, denoted with the C. Capacitance, right? Capacitance, right? Now, actually, consider two conductor capacitor. In this capacitor, the conductors are maintained at a potential difference V. Okay. Anyway, the capacitor is defined as the ratio of the magnitude of the charge, on one of the plates to the potential difference between them. Okay, I will draw one small diagrammatical representation. So this is called one plate and this is another plate, right? Now there is one charge, is existed in these plates 1 and 2. These are the plates. This is 2. Anyway, you can take any one. This is 1 and 2. Okay. Now the definition of the capacitor, definition of the capacitance defined as it is defined as the ratio of the I will write this one, the ratio of the charge, the ratio of the magnitude of the charge, very, very important, magnitude of the charge, the ratio of the magnitude of the charge, magnitude of the charge denoted with Q, to the on of the plates to the potential difference between them, is denoted with B. Potential difference between them. That's it. This is about the capacitance. Now I will write direct expression. So that is called, I will write direct expression C equal to Q by V, charge per potential difference. Okay. Anyway, now what is the meaning of Q? Q, I may write Q equal to integral with respect to volume rho V dV. Then what about rho V from the Gauss law? Q equal to, with respect to V, rho V means del dot d bar equal to rho V. Once if I apply divergence theorem, surface to volume, now volume is existed, finally Q equal to integral, now yes, converted to surface, now divergence is removed, then d bar equal to ds. Okay, then what about d bar? D bar equal to epsilon E bar. Now finally I will write here epsilon integral E bar dot ds. Okay, then what about the potential with respect to E? Already discussed in the previous lectures. There is electric field intensity with respect to length, that is V. Finally V E bar dot dl. Okay, this is about the capacitance. Now I will discuss one by one about the parallel plate capacitor and coaxial capacitor, right? And final one, there is a spherical capacitor. Then start with the parallel plate capacitor. So I will start with the very simple concept. There is two parallel plates already I have drawn just now. Parallel plate capacitors or parallel plate capacitance. Anything, no issue. Parallel plate capacitor, right? In this parallel plate capacitance, there is some direct expression is there. If I take rho s, I will write as rho s direct expression. If I take all the mathematical part, no issue. Then I will write rho s equal to q by s, or we may write q equal to rho s ds and q equal to rho l dl. Okay, now here considered parallel plate capacitor, then charge is existed. Okay, now the ideal parallel plate capacitor, the separation between these two plates is denoted with D. So here D is also very important parameter. Now already we solved one equation in electric field intensity for continuous charge distributions, that is called, there is one expression is there that is called E bar equal to, so I will take down this expression from this side, left hand side. Then another expression is there that is called E bar equal to rho s by epsilon, with the direction is minus ax bar. Already I have discussed in the previous lectures. Just to go through it. Okay, if I write only d bar, this d bar is equal to epsilon e bar. Now another expression is also there, d bar equal to minus a rho s into ax bar. Okay, both are same, no issue. Okay, now what is V? Actually, we already discussed about this V. If I take 2 to 1, there is parallel plates is there now. From 2 to 1, so I will write minus of E bar dot dl. Now I will derive the capacitance of two parallel plates. So there is expression is there, V equal to minus integral 2 to 1, then E bar dot dl, Okay, what is the between the distance, that is called d bar, d only d, then I will write directly. So 0 to d, there is a distance is there. So in the E bar place, I will substitute some expressions. So I will extend this one. So rho s means q by s. Okay, rho s means q by s. Then as it is, epsilon is also existed. Epsilon s minus ax bar. Now then E bar equal to, first E bar in the place of E bar. I will write minus. That is called. Then finally minus into minus is plus, but you have to write here minus q by epsilon into s. There is direction is ax bar. Then there is dot is also there. Then dl means there is x side or x dimension. Then I will write dx with ax bar. Then ax bar dot ax, this is 1. Now I will write the final expression. Equal to minus into minus plus, doing some mathematical part. This is 0 to d. Here q by epsilon s is all is constant. Here only one is there, so this is dx. here constant is there, then expression is x. If I substitute lower limit and upper limit, the final expression is qd by epsilon s. Okay. Now anyway, thus I will write the final expression: parallel plate, parallel plate capacitor, parallel plate. One second, I will rewrite this expression. Parallel plate capacitor, that is C equal to Q by V. C equal to Q by V. Then substitute this expression about this equal to V. Then finally Q by about this V, that is called Q into D by epsilon S. Then finally Q get cancelled. So epsilon S by D. So this is the capacitance C equal to epsilon S by, there is a distance. Okay, I will take the box. Okay, now this is about the parallel plate capacitance. Next, I will discuss about coaxial capacitance and spherical capacitance. Then I will take new slide, that is 13th one. Okay, already in my description I will provide entire data. Okay, then just go through it. Okay, now I will go with the coaxial capacitance. This is also very interesting and very easy. Simply I will write about this coaxial capacitance, coaxial capacitor. Okay, I think this is the last topic in this chapter. Okay, coaxial capacitor. I will write direct expressions. Q equal to the actual expression is del dot d bar with rho v. Then doing some all mathematical part, I will write direct expression Q equal to epsilon e bar dot ds, Okay, what is the meaning of ds? If you consider the coaxial, so considered Gaussian surface, Gaussian cylindrical surface, then ds that is called area 2 pi rho l. Okay, the meaning of ds, total area for the coaxial ds equal to 2 pi rho into l. So substitute this ds with the place of rho, ds with the place of in the expression, then 2 pi rho l. Now q equal to what happened? Doing this integral ds, q equal to epsilon. Just we can write as it is this e bar, no change in this e bar. Now this ds equal to integral ds equal to 2 pi rho l. Finally e bar equal to q by 2 pi rho with respect to al, rho l and a rho bar, the direction. Already we derived in the previous lectures. Just go through it. Whatever we get the e bar, simply we can substitute in the expression V, potential V equal to minus 2 to 1, then e bar dot dl, substitute one by one. This is equation 1. In equation 1, substitute e bar and then dl may write d rho a rho bar. Okay, dl may write d rho with respect to a rho bar. Substitute one by one. Now v equal to integral 2 to 1. Okay, 2 to 1. So e bar means q by 2 pi rho l a rho bar dot dl means d rho aero bar 1. Then the final expression is minus 2 to 1 q by, this is 2 pi L. This is also constant. This is called 1 by rho. Okay. Okay, rho. So this is one expression is there. Okay, 1 by rho with respect to d rho. Once take common this all q by 2 pi L, then 1 by rho, integration of 1 by rho, we may write ln rho. Okay, one substitute in the place of this d to 1, 2 to 1, I will write a b to a. I will write this is b to a. Now this is after doing integration part, the final expression, then minus minus get cancelled. 2 pi L, rho means ln rho, one substitute upper limit and lower limit, the final expression is ln b by a. Okay, this is about the coaxial capacitance. If I write the final expression, this coaxial capacitance, so finally C equal to q by v. So q means 2 pi epsilon L by ln, means q get cancelled, ln b by a. This is about coaxial capacitance. I will take one box of this expression. Okay, then I will go with immediately spherical capacitance. Very, very easy topic about this spherical capacitance. Take the heading of the spherical capacitor. Okay, now the next topic is spherical capacitor. Okay, so now this is also same discussion like as parallel plate and coaxial capacitor. Okay, give me some time. I will complete the session as early as possible. This is spherical capacitor. Okay, I will write direct expression. Then q equal to integral epsilon e bar dot ds, doing all the mathematical part. Then substitute in the place of ds, integral ds of this spherical, I may write 4 pi r square. Substitute all the values, then the final expression e bar equal to, then charge q by 4 pi r square with the direction of ar bar. Okay, we know already about this expression v. Then v equal to minus 2 to 1. This is e bar dot dl. Substitute 1 by 1. So taking the part b to a, this plates. This is one is q by 4 pi epsilon. Epsilon is also very important here. Epsilon 4 pi epsilon r square. This ds equal to 4 pi epsilon. This is epsilon. I forget this one. This is epsilon. 4 pi epsilon naught r square with respect to ar bar. This is dl. Now, based on our convenience, we can write anyway dl, dx, ax bar, dr aero bar, dr aero bar, ar bar dot ar bar 1. Then final, this 1 by r square integration, 1 by r square integration equal to minus 1 by r with respect to dr, minus minus get cancelled. After substituting this lower limit and upper limit, the final expression is q by 4 pi epsilon naught, substituting this lower limit and upper limit and lower limit to 1 minus a by 1 minus b. Now the final expression for the capacitance of the capacitance of the spherical capacitor. Capacitance of the spherical capacitor. Okay, that is actual expression C equal to Q by B. Now Q get cancelled. There is final expression 4 pi epsilon by 4 pi epsilon by 1 by A minus 1 by B. That's it. Okay, this is about the spherical capacitance. This is about the spherical capacitor. Okay, spherical capacitor. Anyway, we derived three expressions. One is the spherical capacitor C equal to 4 pi epsilon. Okay, I will take the box also. Give priority all the expressions as it is. Okay, right. 1 second. Yes, is it will get clear. This is called spherical capacitance. Okay, this is about the spherical capacitance for coaxial cable C equal to 2 pi epsilon L by ln B by A. Then before discussed about this one, that is called parallel plate capacitor. The parallel plate capacitor is C equal to epsilon S by D. That's it. Okay, thank you. Keep watching. I will update more videos on magnetostatic solving.